Arrhenius gave the first scientific definition of acid and bases. But this theory works only in the water. Why? Let us understand. Dry HCl we are not considered as an acid. Why? Every explanations we will study here. So this is the part 2 ionic equilibrium, and in this video we will understand the Arrhenius acid base theory in a simple and examination oriented way. So when it comes to that, what is mean by Arrhenius acid? Arrhenius acid is that any substance which produces the H plus ion. So for example, I am taking H. It is producing the H plus ion in a water. That we are calling it as a acids we are calling. For example, if you take HCl, when we are dissolving the water, it will release the H plus ion. If you take HNO3, when we are dissolving the water, it will releases the H plus. If you take H2SO4, it is releases the 2 H plus ions plus SO4 2 minus. So here the key condition is, here is the water. So here generally it will releases the H plus ions, it will releases. Actually free H plus ion do not exist in the water. They will combine with the solvent molecule. For example, I am taking the one acid. When I am dissolving the water, it will form it as a get hydrated. It will convert it into hydronium ion. This is called hydronium ion. So some of the acids, it will give only one H plus ion. The type of the acid we are calling it as a monobasic acid. That property we are calling it as a basicity. It is giving 1 H plus ion. That's why basicity is 1. Example, HCl, HNO3. If it is releasing the 2 H plus ion in water, that is called as a dibasic acid. So its basicity will be 2. Example, H2SO4. If it is releasing 3 H plus ion in water, that is called tribasic acid. Is basicity 3. Example, H3PO4. Some non-metal oxide, for example, if you see CO2, it is in the acidic property, but it doesn't have the H plus ion. But when we are dissolving in the water, it will form the H2CO3, and again it will dissociate into 2H plus aqueous plus CO3 minus 2 aqueous. Even metal oxides also, for example Na2O, it is a basic in nature, but it doesn't contain the OH minus. When we dissolve in the water, it will form NaOH. It will give 2 Na plus 2 OH minus ion. This also Arrhenius didn't explain. Even though they are not containing the OH minus H plus, they are acting as a acid and bases. When it comes to the Arrhenius base, what is Arrhenius base? Arrhenius base is the substance when we dissolve in the water, it releases the OH minus ion. Example, if you see NaOH, Na plus OH minus, it is called as a Arrhenius base. KOH, it is also releasing OH minus. Both acid and base must soluble in water. This is the conditions. Key condition is Arrhenius theory is valid. It is valid only when the substance is dissolved in the water. Water is important here. Next one, when we are calling it as a acid, it should produces the H plus ion. When we are calling it as a base, it should produces the OH minus ion. Why Arrhenius theory is limited? Limitation. Now comes to the most important point, limitation. Arrhenius theory, it is works only in aqueous medium. Medium should be water. That's why you can see dry HCl does not behave as a acid. HCl, it behaves as a acid only in water. HCl, we are, according to the Arrhenius, we are not call it as a acid when we are dissolved in the benzene. Second one, NH3 is a base, but it does not gives the ammonia is, NH3 is a base, but it does not give the OH minus ion. It does not contain. According to the Arrhenius, ammonia does not contain OH minus, but it still behaves as a base in water. When NH3 is dissolved in the water, it will form ammonium hydroxide, and further it will dissociate it into NH4 plus OH minus. So NH3 acts as a base only after reacting with the water. Third one, cannot explain the acid base reactions without water. So for example, HCl gas react with the NH3 gas to form the ammonium chloride solid. These reactions happen without water, but Arrhenius theory fails here. Because of this limitation, a new theory was proposed. That theory is called as a Brønsted Lowry acid base theory. We will study that in the part 3. If this explanation helped you, continue with the part 3 to understand acid and bases more clearly.